Hello, I am Tyler Linder, and this is my lab report for Physics 2211 for Fall 2020. And this lab report is titled Oscillations. So first up, we have the introduction. Again, the topic of this lab is oscillations, and the procedure for it is to first upload the given video to tracker software. After that, track the position of the ball per frame during the video in tracker. Once that is done, you find the data points from the tracker software, and once you get those, you transfer those data points to an Excel sheet and then save the file. After that, you edit the GlowScript code that was given in the necessary spots, adding certain values and equations to the code. Once the code is done, you can run the code and upload the Excel file to get the computational models. Also, you can compare the computational models with the Excel data points. The fundamental physical principles of this lab are Newton's second law, the energy principle, force and energy, and finally Hooke's law. So here is the tracker observation. On the left of the image is the video that was observed, and on the right is the graph and the data points of every position of the ball per frame when it was moving. The mass of the object was 0.402 kilograms. The starting position was the vector negative 0.109 for the x value, and then negative 0.636 for the y value, and just 0 for z. The velocity is the zero vector, t equals 0, and the change in time is 1/210. So here is the GlowScript code. First, here are some given data points that we have. With gravity, we have the spring constant, we have the relaxed length of the spring, and then once we have those, we can edit the next lines to specify the vector, which describes both the length and the orientation of the spring. And then also we have to compute the system energies, which are the kinetic potential, the gravitational potential, spring potential, and total energy. Continuing on with the GlowScript, we have this code where it runs in a loop. First, we have to define the initial energies, which were done previously, and then we calculate the gravitational force. After calculating the gravitational force, it'll calculate the spring force on mass by the spring. And then once it calculates that, it calculates the net force. And then after that, it applies Newton's second law. Each time it updates the object's position and the spring. And then also it calculates the energy changing. So once the code is ran and the data points from tracker are uploaded, we first get this energy graph. The energy graph compares the change in time and the energy. The different color lines represent the different types of energies. Here we have the observed versus computational model. This compares the position versus the time of the ball or the object that was seen in the tracker video and the computational model done in GlowScript. Here you see that it is very close. The red is the tracker observation, and so due to human error, it is a bit off, but nearly close to the computational model done with the code. In conclusion, what does this mean? First, we know that the energy principle is satisfied for my model system. The system's change in energy is zero. The gravitational and spring potential energies are invertible. The potential energy and kinetic energy are equal in magnitude. When comparing the two estimates of oscillation periods for x and y position data, y takes longer to complete an oscillation than x. However, y is more accurate. Here we have x being 1.61 seconds and y being 1.55 seconds.